All right, so let's now go through an example to investigate the trade-off of whether aggregating inventory in a central location is better from a more systematic, holistic perspective in the supply chain. So as a reminder, what inventory aggregation means is going from multiple stocking locations to a single centralized stocking location. And so there are definitely advantages and disadvantages to doing inventory aggregation. From an advantage side, we've seen before in the other videos how it can reduce safety stock inventories. And it can also reduce facility costs. Those are the pros. The cons are that it can increase response time to customers, which is a big deal in today's supply chain environments. When we want things fast in a day or 2-day delivery, response time is huge. It also can increase transportation costs to the customers because you're usually further away. You have a longer, what they call last leg to your customers, which increases transportation costs. So to answer the question, should I aggregate my inventory? You need to look at it systematically, and you need to evaluate the total expected logistics cost, which is a combination of inventory cost, facility costs, and transportation costs. So if we look at total expected logistics costs, let's break those three things down. So from an inventory perspective, we need to calculate what's our average total inventory, and then what's the cost per unit of having that inventory. So if you remember from the QR model, we know the average inventory in the system. From the Q part, the EOQ is Q over 2, and then from the R part, depending on whether you pay for inventory at delivery or at ordering, would be either the safety stock or the safety stock plus the expected demand during lead time. And so that's your average inventory in the system. And one thing to note is to remember that safety stock is an average value. So it's the average number of units left when a replenishment order shows up. And remember, H is the holding cost of a unit per year is H. From a transportation cost perspective, we need to know how many orders, how many transportation shipments we make, and then what is the cost of one of those shipments. So the number of orders per year is D over Q, and the cost to transport one order is typically S, and that's the S from the EOQ model. And then in terms of facility cost, we have the number of facilities times the fixed cost per facility. So typically there are fixed costs. Even if it's a smaller facility, you need a manager, a welcome desk, et cetera, et cetera. So there's usually fixed cost. And then potentially the variable or per handling cost could change depending on efficiencies, automation, et cetera. And so that would be then your facility cost. Some things to think about here is we need to make sure that our costs are in the same unit. So in the examples I gave here, my unit was year. So everything is per year. Remember, not always all the data is given that way. So make sure to convert it to a consistent period of time per year is pretty common. The other thing to think about is we're going to do what's called a comparative analysis. So a comparative analysis means, is it better to centralize my inventory or decentralize my inventory? So what is important here is to consider what's relevant. In other words, what changes between those two decisions. So if something is a cost, but it's a constant between those two, it's important to consider from, like, if you're going to report to someone what's the total cost of operating, but it won't influence your decision. And so an example of that may be in facility costs. For example, your handling costs may be the same, and so you don't need to consider the variable part of that equation. And we'll see that with other of these costs as well. So one thing to emphasize is we really want to understand what is changing between these two, and then evaluate that in a comparative analysis. All right, so in terms of let's apply this to this example we did previously. As a reminder, we had 3 facilities in the decentralized one and 1 facility in the centralized one. We already calculated the safety stock in our other calculations in our other videos. And we had said that the transportation cost to demand in the decentralized one would be lower than the one in the centralized. Now we want to quantify how much lower. We also said that the facility cost would be higher in the decentralized option versus the centralized one. Now we want to quantify by how much, and then compare these two options in a quantified number way to see which one is better. So let's do that. So we first need data. So in terms of this problem and in this example, our inventory, we have that 1 unit of inventory costs $100 per unit per year in holding costs. So it's pretty high. So we would assume that we're selling pretty expensive things. And that's for H. And then another piece of information we have is that, if you remember to this example, our lead time from our supplier was the same regardless of where it was in the US. And so if you think about the Q equation there, as long as my holding costs at each facility is similar, which H is given the same, then S is the same, then our cycle inventory would be the same. So there definitely would be Q over 2 at all of either of these analysis, but it wouldn't change much for this example. So we are only going to consider safety stock in terms of inventory costs that would change between having a centralized versus a decentralized option. In terms of transportation, in this example, our transportation to our customers are paid on every unit sold. So it's a per unit transportation cost. So in other words, here you could think about Q is 1. So the order quantity, we're sending 1 at a time to our customers. When does this happen? You could think about this could happen if you're selling cars, a car dealership, which you'll have examples in the homework. This could also happen in e-commerce. When you think about what gets sent to customers, they're usually a single item at a time. And so these are different costs because the regional distribution center, we're closer to our customers, so it costs $1 per unit sold. And from the central single distribution center, it's $1.50 per unit sold. Each facility costs $100,000 per year to operate. That's independent of how many things get shipped out of each facility. And the other thing is our handling costs are similar per facility. So we can keep that as constant in our comparative analysis. And let's assume 52 weeks per year. So let's now take those equations and break them down for our example. So in terms of expected inventory cost, we're going to calculate the average total inventory times the holding cost of a unit per year. In the example we just gave, we know that H is 100 and S is the same, and so we're only going to consider safety stock. And so if you remember from our previous example, we calculated the safety stock in the network. And so it's important to consider the network of safety stock because remember in the decentralized, we have 3 facilities, but we're comparing that network to one that just has a single facility. And so in this example that we did, we calculated that we have less units of safety stock, 2970 compared to 1714 in the centralized system. The cycle inventory Q over 2, we're going to assume is the same in both networks, so we're going to ignore that for our comparative analysis. We are told that the holding cost is 100 per year in any situation. And so we can then calculate our inventory cost per year, which is lower in the centralized system. And you should, from kind of a check intuition, that should make sense because the safety stock goes down when you have fewer stocking locations. Okay, so if we only cared about inventory, we'd say we want a centralized system. But inventory is not the whole problem. We also need to consider transportation. So if you look at the expected transportation cost, remember that's the number of orders transported per year times the cost to transport one order. So in our problem, we were given this information, right? We're given that it's paid on every unit. So in other words, Q is 1 in this example. And the cost per unit does vary whether it's in a centralized or a decentralized system. So as another reminder, we know weekly demand, which is normally distributed with a mean of 1,000 and a standard deviation of 300. And so what we need to figure out is how much demand per year is happening. We need D, big D. And so expected demand per year in both of them is 156,000 units. How did we calculate that? Well, we know the weekly demand, and remember expected values, we can use normal math, so we can use summations and multiplication as expected with expected values. And so we have 1,000 per week per facility times 52 weeks per year times 3 facilities, which gives us 156,000 units per year. And the centralized system, the demand didn't change. We only now have 1 facility, but it's all 3,000 pieces of demand per week are centralized there. So that's D. And then we have Q. So the order quantity sent to demand customers is 1 in this example. This won't always happen. So this is an example. The why is Q1 is because it said per unit transportation cost, or transportation costs are paid on every unit sold. That means in this example, Q is 1. If that wasn't the case, and you maybe needed to first figure out Q in the QR model, you would use that here. And so now we can figure out how many orders are transported per year. This is D over Q. In both situations, we have 156,000 orders per year. And we pay $1 per order for the decentralized system and $1.50 per order in the centralized system. And so the transportation costs are higher in the centralized system and lower in the decentralized system. That is usually the case because, again, the distance, the last leg to your customer, is larger in a centralized system than a decentralized one. And so if you have really high transportation costs, if you have small order sizes, or if you have lots and lots of demand, transportation costs can easily make up for any savings in inventory. All right, so that's the first two costs. The third cost is facility cost. And this is usually relatively straightforward. Is the facility costs are the number of facilities times fixed costs plus the variable costs at each of these facilities. As a reminder for the data for this problem, we have that each facility costs $100,000 per year to operate independent of output, and our handling costs are the same, and so we can ignore the variable part of this equation from a comparative analysis perspective. And so again, we have 3 facilities versus 1 facility. They cost $100,000 per facility. The variable costs are constant. And so the relevant facility costs are higher in a decentralized system than in the centralized system, which is something, again, common. So you have to pay more facility costs in decentralized versus centralized. And so we're almost there yet to say, which should we do? Should we centralize or decentralize? We need to now calculate the total logistics cost, which is the sum of these 3 costs. So in terms of the inventory cost, we had that the decentralized one was almost 300,000, whereas the centralized one was only 170,000-ish per year. The transport costs are, again, higher in the centralized, lower in the decentralized. The facility costs are higher in the decentralized, lower in the centralized. And if you sum them together, you get that the total cost is lower in the centralized system by about 200,000 per year. So for this example, you would recommend the centralized system is recommended.